Welcome back to Classical Mechanics in 10 micro lessons on James's Physics 101. I am Sir Isaac Newton, and today we tackle circular motion. Have you ever taken a sharp turn in a car and felt pushed outward against the door? It feels like an invisible hand. As convincing as that outward push feels, I am here to tell you that it is one of physics' greatest illusions. In this lesson, we will uncover the real force at work, bust the centrifugal myth, and explain how planets stay in orbit. To understand motion along a curve, we must start with my first law of motion, the law of inertia. An object in motion will keep moving in a straight line at a constant speed unless acted upon by a net force. Velocity is a vector. It has both magnitude, which is speed, and direction. If you change either, you change velocity. Because acceleration is defined as any change in velocity over time, traveling in a circle is continuous acceleration. Even if your speedometer reads a constant 50 miles per hour, turning the wheel accelerates you toward the center of the turn. This inward-seeking acceleration requires an inward net force. We call this the centripetal force. The formula for centripetal force is F equals mv squared divided by r, mass times velocity squared over radius. When a car turns, the centripetal force is provided by static friction between the tires and the asphalt road. If you whirl a stone on a tether, tension in the string provides the inward pull, keeping the stone in its circular path. What happens if the string snaps? The stone does not fly directly outward. It shoots off in a straight tangent line. The moment centripetal force disappears, inertia takes over, and the object resumes its natural straight path. So why do you feel pushed outward against the car door? Welcome to the illusion of centrifugal force. Your body wants to keep traveling straight. As the car turns around you, the car door turns into you. From an outside observer's stationary frame, the door pushes you inward. That is the real centripetal force. Inside the rotating reference frame of the car, it feels like an outward force. Physicists call this a fictitious force. A laboratory centrifuge operates on this principle. Inertia separates dense particles, while the tube walls push inward. Remember, centripetal force is a real physical interaction. Centrifugal force is simply your inertia resisting a curve. Now, let us scale this concept up to cosmic proportions and talk about gravity, moons, and orbits. Gravity acts as nature's invisible tether. It supplies the centripetal force that keeps satellites circling Earth. To explain this, I devised a thought experiment known as Newton's cannonball. Fire a cannonball slowly, and gravity pulls it to the ground. Fire it faster, and it lands much farther away. If you fire it fast enough, about 8 kilometers per second, the curve of the ball's fall matches the curve of the Earth. The cannonball is literally falling toward Earth continuously, but because the planet curves away beneath it, it constantly misses. Astronauts aboard the space station are not in zero gravity. They are in perpetual freefall, floating together with their ship. From sharp car turns to planetary orbits, circular motion is all about a constant inward pull, bending straight inertia. Master the motion. Subscribe to James's Physics 101. Leave your questions below, and I will see you in Lesson 7 on momentum.